Hello everyone, welcome back to Masth Electronics. Today we are going to convert our Raspberry Pi into a NAS cloud server. Here is the Raspberry Pi 3B Plus model. We will be using this to create our NAS cloud server. For cloud storage, we will use an 8 GB pendrive. In this setup, we will not connect any display to the Raspberry Pi. So we will be flashing Raspberry Pi OS Lite 32-bit version. We have a 16 GB memory card which is sufficient for this project. To flash the OS, I am using a card reader. Let me connect it to my laptop and start flashing. First, I'll download Raspberry Pi OS from the official Raspberry Pi website. The link is available in the description below. I'm using the Raspberry Pi OS Lite 32-bit version. I have already downloaded it. Now let me open the Raspberry Pi imager. Since I have already downloaded the OS file, I'll select the Use Custom. Click Next, select the memory card and click Write. Now the flashing process will start. Flashing is completed. I'll remove the card reader and connect it back to the laptop. Now the boot partition is visible. Inside this, we need to create a file named SSH to automatically enable the SSH. Next, we create another file named userconf.txt. Here we need to add username and password, but not the plain password. We must use a hashed password. For that, I'll open Windows PowerShell. We need OpenSSL to generate the hash password. Let me check. Yes, it is installed. If you don't have it, you need to install it first. Now I'll run OpenSSL passwd-6. Enter the password. This generates the hash. I'll copy it. In userconf.txt, enter username, and this hash value. That's it. Now I'll insert the memory card into the Raspberry Pi. For network and internet, I'm connecting Ethernet cable. I tried Wi-Fi earlier but it didn't work properly, so I'm using Ethernet for reliability. I'll also connect the pendrive for storage and power on the Raspberry Pi. Hardware setup is ready. Let's connect using SSH. My laptop is connected to the same router network. Now we can SSH into the Raspberry Pi. We can connect using IP or hostname. If hostname works in your network, you can use it. Otherwise, scan and find the IP address and connect using that. Enter username and connect. Accept the prompt if it asks yes or no. Enter the password. Now we are connected. First, let me update and upgrade the system. Update is done. Let me reboot once. I'll reconnect through SSH. Now I'll configure localization options. The pendrive is already connected. Let me check. Yes, it is visible. I'll unmount and format it. I'll create a directory and mount the pendrive there. Let me verify. Yes, it is mounted. Now we make this mount permanent using UUID. Copy the UUID, open fstab using Nano Editor and add the entry at the bottom. Save the file using Ctrl O and exit using Ctrl X. Unmount and run auto mount. Yes, it works. Now I'll create a shared folder and give permissions. Next, install Samba for file sharing. Open smb.conf and add the share configuration at the bottom. Now add the username to Samba and set a password for NAS access. Restart Samba service. Use ifconfig to get the IP address for remote access. My phone is connected to the same Wi-Fi. In the file manager, add a LAN storage device using IP, username and password. Yes, connected. Let me create a folder. Yes, it is visible on the Raspberry Pi. So local NAS is working now. Right now this works only inside the same network. If we switch to another network, it won't connect. Let's fix that securely. First, firewall settings. Install UFW firewall. Allow SSH and Samba and enable firewall. Now instead of exposing our NAS directly to the internet, which is dangerous, we will use Tailscale VPN. This creates an encrypted private tunnel between devices. Install Tailscale on Raspberry Pi and run it. It gives a login link. Open it on your phone or laptop and sign in. Approve the device. Now install Tailscale app on the phone and log in with the same account. You will see Raspberry Pi listed there. Now disconnect Wi-Fi and switch to mobile internet. Use the Tailscale IP address to connect to the NAS. Yes, it connects even from outside the home network. Let me create a folder. Yes, it appears on the Pi. so remote NAS access is working securely. Now let me quickly talk about security and how safe this setup is. In this project, we are not opening Samba or SSH ports directly to the internet. That is very important. Direct port forwarding is one of the biggest causes of NAS hacking. Instead, we are using Tailscale, which is based on WireGuard encryption. It creates private device-to-device secure network. Only devices that you approve in your Tailscale account can connect. All traffic is encrypted end to end. Because of firewall rules, local permissions, password protection, and VPN only remote access. This setup is considered safe for personal cloud storage and learning use. Can users follow these steps confidently? Yes, if they follow exactly. Use strong passwords, keep the system updated, do not enable guest shares, and never port forward Samba. Is it 100% hack proof? No system connected to the network is ever 100% hack proof. But this design removes the most common risks and is much safer than exposing a NAS directly to the internet. For home lab, personal cloud, backups, and learning, this is a secure and practical setup. Finally, we have converted our Raspberry Pi into a NAS server. That's all for now. If you found this helpful, give it a thumbs up. If you want to see more useful and practical projects like this, please subscribe to Masth Electronics.